It is an astronomical roller coaster of superlatives. While Venus was initially thought to be Earth's cosmic twin and then recognized as its toxic stepsister, our neighboring planet is suddenly suspected of harboring life again. Did the Soviets already have this exciting speculation in the back of their minds when they sent no fewer than 28 research probes to Phoenix between 1961 and 1983? Well, who knows, but it's a fact that the ambitious Venera program was by no means only crowned with success, but was marked by crashing failures, especially at the beginning. Despite all this, the mission also provided groundbreaking new insights, and one of them is now coming back into focus. When it comes to the hotly debated question of life on Venus, some dates have probably been etched forever in the memory of every space fan. Of course, there is July 21st, 1969, the day when Neil Armstrong and Buzz Aldrin became the first humans in history to set foot on an alien celestial body. But just like the first successful moon landing, April 12th, 1961, is unforgettable. After all, this was the day that Yuri Gagarin became the first man in space. But did you know that December 15th, 1970 also marked an outstanding milestone in space travel? In fact, the Soviets achieved something that no one had ever done before with Venera 7. They made the first soft, or in other words, unmanned landing on the surface of another planet. As you might expect, it was Venus that had become the focus of Soviet research interest, and yet it was a long way to the successful realization of this project. In truth, the origins of the Venera program go back to the early 1960s, but the first probe launches all ended in full-blown disasters. To understand how much our understanding of Venus has changed since then, it's worth taking a brief look at the following. After it was leaked in 1961 that the Soviets wanted to send 2 probes to our neighboring planet, the West suspected that these were designed to be able to float in a full-blown ocean. Yeah, you heard right. While boiling hot Venus, with its toxic clouds of sulfuric acid, can confidently be called a hell planet today, it was still believed until the early 1960s that our planetary sister resembled a primeval Earth covered by seas and forests. An undoubtedly exciting notion, but one that has since changed somewhat. Although Venus and Earth are indeed similar in terms of size, mass, density, and internal structure, like one planetary egg inside the other, the differences elsewhere could not be more dramatic. The Earth's average temperature is 15 degrees Celsius, but on Venus the thermometer climbs to an average of 464. To the ocean on Venus that was suspected before the launch of Venera is also missing in reality. No wonder, after all, the gigantic planet-spanning cloud layer is not, as previously suspected, a water cloud, but a corrosive veil that contains not only sulfuric acid but also aerosols containing chlorine and phosphorus. In view of this, it's not really tragic that Venera 1 did not carry a special ocean lander with it when it was launched in 1961, but what was all the more tragic was the fact that contact with the probe was lost completely just a few days later. Despite all this, the silent spacecraft is officially considered to be the first artificial object to enter the realm of Venus on May 20th, 1961. The rocky road to success, admittedly, this is little consolation and cannot hide the failures that followed. While the USA succeeded in sending the first probe to Venus, Mariner 2, on December 14th, 1962, which then also sent usable data back to Earth, the Venera program initially only attracted attention due to further failures and serious contact problems. And yet, since March 1st, 1966, Venera 3 has been able to adorn itself with the title of being the first space probe to crash onto the surface of an alien planet. The applause from those in charge when Venera 4 finally managed to successfully deliver data from the atmosphere of Venus in 1967 must have been thunderous, too, and gave the Soviet Union the long-awaited sense of achievement. But all was not plain sailing for the Soviets either. While we now know that the atmospheric pressure at the surface of Venus is 92 bar, the members of the Venera 4 mission were not aware of this fact. As a result, the probe descended more slowly than predicted, which ultimately prevented it from reaching the planet's surface within the planned operating time. Despite this, the data it did collect provided important new insights. For example, that the temperature 25 kilometers above the surface is 270 degrees Celsius, and that the atmosphere of Venus consists mainly of carbon dioxide, along with small amounts of nitrogen, oxygen, and water vapor. Venera 5 and 6, launched in 1969, also fell victim to the immense pressure on Venus. But since the probes were able to send data about the atmosphere to Earth again, the double launch was retrospectively deemed a success. 2 squash space probes later, the moment had finally come for Venera 7, and as mentioned at The beginning on December 15th, 1970, it became the first space probe in history to safely land on the surface of another planet. What did the Venera probes discover on Venus designed to withstand a pressure of 180 bar? Venera 7 transmitted a weak signal to the research stations on Earth. For just under 25 minutes in the process, it provided experts with the knowledge that temperatures at its landing site were ESC scorching 475 degrees Celsius, and also with the information needed to develop a follow-up probe that could explore our extreme sister world even more extensively and with success. When Venera 8 landed on the day side in July 1972, it found that the surface of Venus was as bright as an overcast day on Earth, and despite the fact that only 11 seconds of the 50-minute data transmission from the surface were used, the experts now knew that ammonia exists on Venus and that potassium, uranium, and thorium are found in its soil, and yet the exploration of Venus was still accompanied by a major drawback. After all, it hadn't been possible for us to catch a direct glimpse of the planet's surface. However, after Venera 8 had shown that photographing on Venus was possible in principle, Venera 9 and 10 finally gave us the first images. In October 1975, the low-resolution black and white images showed a relatively smooth terrain, peppered with stones and boulders, and actually Venera 11 and 12 should have brought a little more color into the Venus game 3 years later, but unfortunately the camera's cover would not come off. And so it was that humanity had to wait until March 1982 before Venera 13 and 14 provided the first high-resolution color images of Venus. In the same breath, the microphones of Venera 13 also captured the sounds of the Venusian wind, allowing us to listen to the spectacles of another planet for the first time. In 1983, Venera 15 and 16 once again turned their probe attention to mapping the planet's surface, and yet it was the Melon probe launched by the USA 6 years later that gave us the first global map of Venus. From 1984 to 1986, the Soviets completed 2 more successful Venus programs with Vega 1 and 2, and yet these planetary excursions took place around 40 years ago. But if the Russian space agency Roscosmos has its way, the long wait will soon be over. After all, the Venera legacy is to be continued in the near future. More specifically, the Venera D mission is scheduled for the end of 2029 at the earliest, with a probe consisting of a satellite, a landing platform, and a balloon floating in the atmosphere. Venera D will explore the atmosphere of Venus, take a closer look at any volcanic activity, and perhaps even provide proof that our neighboring planet is home to extraterrestrial life. The question of life. Before we delve deeper into this fascinating topic, we should briefly clarify another question: what is left of the Venera probes today? Well, since the surface of Venus is naturally hidden behind a thick veil, we cannot answer this with absolute certainty, and yet it's considered likely, to say the least, that the immense heat has completely charred all materials used, components such as cables and seals. Shortly thereafter, sulfur dioxide and other acidic gases entered the interior of the probes, corroding and oxidizing the metal parts inside. And if you want to visit our channel, Digital Discoveries, again soon, you can now simply click on the subscribe button. We would love for you to join our community so you never miss a new video from us. Again, we'll see you soon.